All right, we got number 3 here. The goal is, I probably marked on here already, is to find where it's increasing, decreasing, concave up, concave down, local extrema, inflection points. There's a problem written right through it for this function. Oh boy, I know, try to contain yourselves. So we got y prime equals first times the derivative of second, e to the 1 over x squared, times the derivative of the exponent, which is negative 2 over x cubed. That's this right here. Write down, oops, not that. Oh yeah, I guess you can. Write down 1 over x squared is x to the negative second. The derivative is negative 2x to the negative third, which can be written by negative 2 over x cubed. So we got first derivative of second plus the second times the derivative of the first, 2x. Okay, now I'm going to set that equal to 0. So I want to factor that. So I'm going to factor out a 1 over e to the 1 over x squared. And what's left? Well, that x squared cancels with 2 of those. So I'm left with the 2 over x plus, and then over here I've got a 2x. Now I actually could have factored a 2 out as well, but I didn't catch it before I wrote it down, so I'm just going to leave it there and recognize that this right here can never be 0, so that could be 0. So I've got negative 2 over x plus 2x equals 0. And I'm going to solve that for x, so I'll multiply both sides by x. So I get negative 2 plus 2x squared equals 0. 2x squared equals 2. X squared equals 1. X equals plus or minus 1. And so we're going to do this. Make my number line. These are my critical points. By the way, let me go back up here. I didn't have to worry about critical points when it doesn't exist, because it doesn't exist when x is 0, but my domain, x can't be 0 in my domain because I can't divide by 0 here over here, so I don't have to worry about the critical point when x is 0. So I've got negative 1 and 1 on my number line. However, since the domain 0 is not in the domain, on my number line, I still need to think about it because it could still change from positive to increasing at 0. I don't know if there's an asymptote there. I don't know if there's a hole there. I don't know what the graph looks like exactly. So I have to take that into account when I do my number line here. And I consider where it's changing from increasing to decreasing. So I've got to look at y prime in each of these areas. Does that make sense? Okay, I mean, my classic example is 1 over x. Changes from decreasing or concave down to concave up at 0, and it's undefined at 0, for instance. Right? It goes from decreasing to decreasing both places, but it does some things happen even though the domain is undefined at 0. So we still have to just check that out. It's not a critical point because it's not a point in of my function, but the derivative is still 0. So check that out. All right, so where are we at here with this is with my derivative, y prime. So I've got to start checking big negative numbers. You have to recognize, I'm going to change colors here. This right here is always positive, so I'm really only concerned with this guy right here. Is it positive or negative? And so then I come down here and look at a big negative number, and this is where it probably would have been nice to have that 2 out of there. And if I think about this, this is really negative 1 over x plus x times 2, right? Equals 0. If I factored the 2 out of both of those. And so now I'm just really worried, is this positive or negative? So if I pick a big negative number, this is going to be negative, negative. Adding 2 negatives, this is negative. So it's going to be decreasing. Between negative 1 and 0, big negative 1/2. Negative 1/2, that makes this a positive 2 minus 1/2 is positive. between 0 and 1, 1/2. This is going to be negative 2, positive 1/2. That's negative. Bigger than 1 is a big positive number, like 1 over 10 plus 10 is positive. Please don't make the assumption that it just keeps going back and forth. Okay, so this is a relative minimum. 0, I can't say it's a relative maximum because it doesn't even exist there. Relative minimum, but I do know it changes from increasing to decreasing somehow at that point. So it might be increasing, decreasing. Could be something like that. Or it might just be a hole. Might be something like this, increasing, decreasing. Okay, so I don't really know what that looks like without looking at the graph. If this was a calculator portion, I could look at the graph. If it's not a calculator, then I really don't know what it looks like. Okay, so I've got the increasing, decreasing parts handled, and now I have to do, well, we can write it down. Let's go back up to the top here and see what we're doing. So increasing, decreasing, local extreme, inflection, and so forth. Okay, so we got increasing on negative 1 to 0 and 1 to infinity, decreasing negative infinity to negative 1 and 0 to 1. Excuse me. Okay, we've got a relative minimum at x equals negative 1. We've got a relative, and 1. So what are the points correspond to? Well, we got to plug it into the original function, x squared e to the 1 over x squared. So it actually happens at negative 1, and then x squared e to the 1 over x squared is just e to the 1 over 1, right? So that's just e. And this one is at 1e. Okay? So we're good there. Then we have to look at second derivative. This is a long problem. Okay, so we got second derivative. So we got to talk about concavity. So now I've got to look at this guy. So I'm going to write down, it's going to be slightly off the screen, and then we'll move it up, equals, I'm going to factor the 2 out, e to the 1 over x squared, and I'll get negative 1 over x plus x. So there's my that's my first derivative. See if my eraser works here. Been having problems with that. Okay. Alright, so there's the first derivative. So we got to take second derivative. So y double prime equals first 2e to the 1 over x squared times the derivative of the second. So think of this as negative x to the negative first. So the derivative of that is going to be, did I say first? I'm sorry if I said first something. I just got to take the derivative of each one individually, but the second is the whole thing. Sorry, I had to pause it there, so it's going to be chopped. So I've got first derivative of the second, which is the derivative of each of these pieces. So that's going to be x to the negative second plus 1, first or a second, plus a second, times the derivative of the first. And the derivative of the first is this. E to the 1 over x squared times the derivative of the exponent, which we said was x to the negative second, so it'd be negative 2x to the negative third. Okay, yuck, but you can do this. Okay, so let's do some simplifying here. Looks like I've got 2 terms here, right? Got this first term plus this second term. So I can factor out a e to the 1 over x squared. I can factor out a 2 e to the 1 over x squared, so forget that. E to the 1 over x squared. And then what's left? Okay, we've got a 1 over x squared plus 1 plus negative 1 over x plus x minus times negative 2 over x cubed. Alright, I want to make sure I'm not making mistakes because I factored this guy's gone, so I've got that. Okay, so you've got 2e to the 1 over x squared. You have to pay attention to tedious stuff like this. It doesn't change later on in math or science or anything else that you're going to be heading into probably. So we've got 1 over x squared plus 1, and then let's distribute this. This is going to be plus 2 over x to the 4th minus 2 over x squared. And that's y double prime. Okay, so don't worry about that yet. We just want to set it equal to 0 because we want to find inflection points and where it's concave up and concave down. Okay, well, inflection points happen when y double prime equals 0 and it changes sign, right? So we want to set this equal to 0. Well, that's never 0, so let's set that equal to 0. Oops, let's do it like this. 1 over x squared multiply through by x to the 4th. So I'm going to have an x squared plus x to the 4th plus 2 minus x squared equals 0. So this becomes x to the 4th. Looks to me like I'm losing my x squareds. Looks to me like I get x to the 4th equals negative 2, and so therefore I get no solution, which tells me that nowhere is y double prime equal to 0. Now, is that accurate? Let's make sure that I didn't make any mistakes here. And it looks like I did as I'm looking up here, multiplying this. Oh boy, sorry about that, guys. Okay, I paused it in the middle of it there and had to take care of something and I lost it. No excuses though. So negative times a negative, so that should be a positive, right? After I multiply it out, oh, I did it. So positive. That should be a negative, sorry. After I multiplied out. So no, that's good. That was a negative and a positive down here. That did become a positive. This negative and this negative should be a positive. Positive, positive. Oh, look, they don't cancel. So plus 2 plus 2x squared. So I'm going to change these. So this becomes a plus 2x squared plus 2 equals 0. Okay, so let's erase the rest of that. Okay, so now let's keep on going. Don't give up on me here, guys. Now I got to know, when is this ever 0? Well, no matter what I plug in for x, this is always going to be positive, right? So it's going to be concave up everywhere. Okay, this is, so first of all, this is never 0, and by double prime is positive for all x where it is defined. Okay, does that make sense? So it's concave up everywhere. So concave up negative infinity to 0 and 0 to infinity. And no inflection points. And I think that answers everything. Okay, sorry about that little hiccup, but that happens and we're good to go.